Do you like my dress? I like my dress. Isn't it cute? It's got birds on it. We are back, which is crazy because it's been a forever amount of time off because, let me explain, my last semester of college was really nuts, and for the last month I have been road tripping across the country, so here we are in California. This is where I live now. As I was completing said road trip across the country, I was doing a lot of camping and therefore making some campfires, and it occurred to me that I don't know why things burn, or what flames are, or what fire is. And I thought that would be a perfect topic for reigniting lunchbox science. So fire, on the most basic level, is a chemical reaction between the oxygen in the surrounding environment and whatever fuel source you have. So in a campfire, that's wood. But things just don't light on fire because they're in contact with oxygen. For fire to occur, you need a lot of heat. And depending on what your fuel source is, the heat required is going to change. So every material has an ignition point, the amount of heat required for it to combust. So we've actually got two steps to this reaction here. If we're staying with our campsite situation, we've got the reaction between the wood and the heat. Now this produces essentially what is charred wood, and we'll get to that in a minute, and gas. In the second step of our reaction, the gas interacts with oxygen, and that reaction produces water, carbon dioxide, carbon monoxide, just pure solid carbon, and nitrogen gas. A fire reaction also produces really intense amounts of heat. So this means that a lot of energy from this reaction isn't being created into anything else, it's just being lost as heat into the atmosphere, which is why people use fire to warm themselves up. This is one of the coolest parts. The heat is why we have flame. All of those carbon and nitrogen and water molecules that are being released from this reaction are being heated by the energy that's also been released. And this is making them incandesce, essentially glow. So remember in the first part of that reaction where I said that heat plus wood equals charred wood and gas? So now we know what happens to that gas, right? It reacts with oxygen to produce more gas and some solids like carbon. And charred wood is all of those things in the wood that are unburnable. So depending on the wood, depending on the environment, any elements that can't actually combust. Speaking of things that don't catch on fire, only some materials have bonds that are weak enough to be broken by the energy provided by heat. Wood, for example, has weaker bonds than, say, metal, which means it's easier to break those bonds with an energy force like heat. And depending on the metal, metal's bonds can be really strong, which means it's going to take a lot of energy in the form of heat to break those bonds and dissolve it into a gas. This strength of bond force combines with metal's conductive properties. So metal is really good at transferring heat from one thing to another, which is why we use metal in pots and pans for cooking. But this also means that it conducts heat away from the heat source too fast for the metal to ever reach ignition temperature. So it's too good at its job to ever become hot enough to burst into flame. Another question. Since fires require oxygen to burn, can we light things on fire in space, which is a vacuum devoid of oxygen? The answer is yes! If you bring your own oxygen with you. NASA and other space exploration organizations have discovered that fire is particularly dangerous in spacecraft because unlike on Earth, you don't have any gravity to keep the flames going just up. In space, flames are a lot more unpredictable depending on the pressure of the vehicle and gravity, if you have any, if you don't. People actually are continuing to be surprised by how fire and flame behave in space. And there's a really cool article from the Smithsonian Institute that you can click on here to read more about that topic in detail. But back to fires on Earth. Sometimes they can get out of control in nature, especially during a drought when things are easier to burn. But on a smaller scale, natural wildfires are actually really good for ecosystems. So smaller wildfires are taking care of all of that underbrush, any dead material that is lying about just waiting to burst into flame. It sort of clears that up, keeps the ecosystem healthy, and boosts ecological diversity, both plants and animals. So then when something catches on fire, there's not a lot of things for it to eat up in its fiery path. So in an area that is allowed to experience natural wildfires on a regular basis, it's much less likely that you'll get a really large, dangerous, out-of-control wildfire. So we've covered everything from how fire works to why it's good for the environment to how it burns in space, and this is just a general overview. So if you're interested in any more of these things, you can contact me on Twitter, Facebook, Tumblr with questions or comments. And I need more questions from you to keep Lunchbox Science going, as always. So every week I'll be answering questions from viewers just like you. You can send them to me via any of those avenues: Facebook, Twitter, YouTube, Tumblr. And I really want to hear from you, and I've missed you a lot, so thank you so much for listening, and I'll see you next time. Don't forget to pack your lunchbox.